Okay. I guess I have to go to the screen. That will help. All right. Good afternoon. I hope everyone's having a splendid 4th of July. This is rather typical of my 4th of Julys as a space scientist. I think I've worked more than half of them because you're usually getting ready to deliver hardware to something, which makes the relatively small attendance at this activity somewhat discouraging. I don't think you guys really understand exactly how much trouble this project is in. I was actually expecting everyone to be here.
Well, I did tell them that they didn't have to be here. That's my fault.
Finally, it's because this is my last day. I will be here one day between now and when we should be. Well, on the 28th of July, we should have fully assembled payloads ready to go, ready to at least begin thermal and vacuum testing. If we're not, we're pulling the plug. Okay? The problem is I will be here a grand total of one day between now and then, which means we are way behind schedule. That one day is Wednesday. I believe it's the 16th of July. Those of you who have employment on Wednesdays would be well advised to change your schedule for that week, so we can actually benefit from my one day. Now, actually, I'm actually in town on Tuesday, but I have to teach a class at the Lunar Planetary Institute and spend some time at my other office, which I haven't been at all summer. So at least until about 3 o'clock on Tuesday. Now, if there will actually be people who want to work with me, you have to actually let me know and then keep the appointments. So that's the real hard nuts of the schedule. 16th of July is your next shot at me. By the 28th of July, we have to have 2 assembled payloads ready to go through thermal testing and vacuum testing. If we aren't at that point, we pull the plug on the test flights.
Is that something that we can do before then? Get enough time?
What?
Is that something that we can do before July 16th? To get things ready?
Oh yeah. No, I'm just telling you what the if the the problem we face is, I'm telling you what the drop dead dates are. In other words, if you have the payload ready before the 28th of July, maybe that's one thing we should do after this meeting, go out in the lab and discuss the actual environmental testing that's required.
Yeah.
The Apropos of the test flights, I have discussed this with Dr. Leffer this morning. Apparently there was some confusion last week, God knows why. Yes, we are taking the Yagi antenna, and yes, we are taking the big high-power receiver. It is also probably the case that I'm not sure Dr. Leffer has told Darrell he's going on this trip yet, and it may not even be Darrell. He was talking about somebody named Bill, whom I haven't met at all. So we need to actually talk to Dr. Leffer and Darrell and make sure that everybody's on the same page vis-a-vis travel. I will be there from the 7th to the 9th or maybe the 10th. My son expects me to teach him fly fishing on the 10th, which is sort of an issue.
Well, I mean, luck flying on the 18th.
Yeah.
It doesn't depend completely on the weather.
Are they planning a morning or an evening launch? Things we need to find out. From one, motel recommendation. 2, what specifically what brand, model, and model number of connector are we going to be using for the command interface, and yeah, we need to know the connection, exactly how the connection is going to go. The those are the things we will need from him. Now, I discussed with Dr. Leffer, we can fly an IMET-R as opposed to a plain IMET. And apparently this was a source of considerable confusion over most of the spring, and one of the reasons apparently very little got done in certain projects is because people kept beating their head against a wall that was totally unnecessary. Apparently several of you spent the better part of 2 months trying to figure out how to get allowed to completely reprogram the boot ROM on the IMET. Completely unnecessary. I don't know why that became the block. We can't proceed till we figure out how to do that, was really what blocked several experiments for the entire team.
For some reason, that's what we thought we would have to do in order to get it not to 30. We don't need it to 30.
Yes, we do, but it's already set up and programmed to accept a 1200 baud input, the R connector. And so all you have to do is, there is somehow defined in the IMET software documentation that you tell it, okay, there is, in addition to the words that we usually send, you've got a 1200-bit stream that you have to interleave with our regular words, our 1200 baud stream. Now that takes setup, but the setup capability is part of the as-shipped software already in the IMET. So somebody needs to figure out how to do that, and if we want to, we don't have to, but that could be plugged to a separate experiment with its own Arduino doing whatever. Okay, so that could be an Arduino Uno or whatever. It could be any one, but we can actually get another separate experiment besides just flying an IMET. And that's actually worth doing in the sense that that is going to be the default configuration for all the latex balloons, using an IMET-R for a 12 plus SD cards. Confusions I have heard about. So let me go on about so that, and it may be that we only test fly that. If that's all that's ready, that may be the situation. I discovered Monday, I guess, that nobody had ordered the connectors for the transmitter when the transmitter was ordered. Apparently that's, well, now that's a question, the connectors and the required modem, except it's not clear it's required. We can directly modulate the transmitter. We could just send it a bit stream. And I talked to Dr. Leffer this morning, and he said he thought that the bit stream could be demodulated without using a modem. What does a modem do? The modem, basically the modem is, it turns digital levels into sounds. I was going to say, you've all heard modems talking on the phone, but most of you haven't. That's an experience that's gone out of your life. But back when modems were part of everybody's home life, if you picked up another line and the modem was on, you heard this sound. And what they were doing was changing the DC level of up, down, which doesn't go through a phone line for shit. into an AC signal, which then can be interpreted. Somehow, for whatever reason, that's still what's being used for digital data links on radios. It's called a double encoding, really. You don't have to do that. You can just put in a 0 to 3.3 DC level shift and decode that. So you could put the US-232 bit stream in directly. That's what I used to do when I, where's that?
Is it easier or more difficult than using a modem?
On our side, it's a lot easier. It's $1,200 easier to not use a modem. On the decode side, it may be a bit more iffy. So what somebody needs to do is get with Dr. Leffer and Darrell on Tuesday and find out for sure that it's okay not to use a modem. Because Dr. Leffer doesn't get back to town until Tuesday. He's on travel.
Is there anybody in this room who can meet with Dr. Leffer and Darrell? You would have to be available all day. So I don't know when
Yeah, this is sort of a necessary precursor. Now we discovered, I discovered much to my horror that there was an email from the XDL vendor about, well, you have to buy all of this with this, that no one showed me. And so you guys made a collective decision, we don't need any of this. And it was all the necessary connectors plus a modem. Plus a bunch of stuff we don't need, like a wall power supply. Now, I went over with you and Hamza what was needed and what isn't. I don't know if we can get all that stuff a la carte, but the big price item of the $1,200 that's going to cost is the modem. Most of that stuff is $50 items. So we need to know, before that order gets placed, we need to know if the modem is required or not, and preferably not.
The thing is, even if it's not required, we can't order any of that stuff from them without purchasing the whole kit. They refuse to sell it to them.
I did not know that. Did they actually say that?
Yes. Hamza emailed them the day after we had that conversation. Email conversation has been forwarded to Abdul, Daniel, and Aaron.
So, and the kit is $1,200?
When they take away the transmitter, because we already purchased it, they haven't actually mailed it yet. So they'll just say, all right, well, we bought the whole kit and send everything else for the same price minus the price of the transmitter.
So it would be $1,200.
Yeah.
Yeah, we should do that. Go ahead and do that. The reason is I think it might be extraordinarily difficult to find all those connectors one by one.
All right.
And the fact is, it's a ripoff, but at least
we have them.
We probably will not use the modem.
Right.
And we're going to need mating connectors to the 30-pin anyway. But this will at least let us test it.
All right.
We may need the modem at the other end because Darrell may not have one. That's needs to be determined. So that's the other part of the conversation with Darrell. Does he have the needed modem? And you need to be rather specific because he was talking about, well, you can just use the NOAA free software, and I'm going, wait, there's 4 different modem conventions, and what they're using is the dirt simple ADL, as they put it. I don't know what ADL stands for. Don't ask me.
All right.
You can Google it, and you'll find out. Okay, if that's the case, then I feel like we're being ripped off.
We are. I think someone might have let us slip that we're a NASA-funded project.
You never say that on the phone. Oh, dear God. You don't let that slip. You say we're a university research project, and use the words undergraduate, but never say NASA funded because that triples the price.
It's a guess.
Hmm?
It's a guess. I assume because $1,200 is still high.
Yeah. I have. I understand that some people feel like it helps get a better deal if they say that. It's exactly the opposite. You can say, hey, we're a university-funded, student-supported research project. You'll get a lot better prices than if the NASA word ever appears in your conversation. I guess that's hard for people to learn. They think saying NASA makes it like we're going to get a price break or something. No, it's the opposite. It's the $600 toilet seat effect. Or it's the difference between those $3 relays and the $500 relay. And by the way, I need the pinout diagram emailed to me of the one we bought. Okay. So the new news about the test flight was we're going to use an IMET-R, and we can have attach experiments to it too. What were the other confusions from a week ago? Each payload will have one transmitter. Somehow the idea has gotten around that each experiment has its own transmitter. I have no idea how that idea started. Each payloads will contain multiple experiments. And you guys need to start functioning much more like a team to put the experiments together, because we may very well have payloads with an auroral experiment and one of the atmospheric constituent experiments. It was never really my idea that all the atmospheric constituent experiments go on just one payload, and that all the rest of the payloads be auroral. That's the way it seems to be playing, but that was never the intent. Part purchase. I'm still not seeing forms with two sets of initials on them.
I didn't hear that word.
Every order form that gets turned in should, line by line, have two students' initials next to each item. And when a student writes their initials next to that line, that means I know what this is and why we're ordering it.
I'm still not seeing forms like that. And I will confess, Rachel, I'm bad. I wasn't insisting. The other thing that should happen, I mean, I signed one form on Wednesday, basically because I was totally harassed and busy, and I shouldn't have, for just a part for an experiment where I haven't seen the block diagram or a drawing. If you want to buy parts for experiments, I have to have seen, or Dr. Leffer has to have seen, a block diagram and a complete drawing of what the thing is, both mechanical and electrical. So that's 3 pieces of paper before we start buying parts. This business of buying a bunch of parts and then seeing if you can slap them together is just not how you do spacecraft. And that's what seems to be going on here. And I guess I can understand that to some extent. Most of you have no experience at all in geometric visualization. And the only way you can design things is to start from the parts and put them together. That isn't how the real world of engineering employment works. It isn't how the real world of science works. You design your experiment massively on paper, where did my project notebook that I had out here go? The one I got out for an example.
It's over there.
Mm-hmm. No, the next one, the big fat guy. Yeah. So this is my last big balloon experiment, the one we flew in 1999. I think it is. Oh, is it? No, this one is. Okay, no, this is out of rocket experiments. I flew a long time before that. This isn't, this isn't the one I wanted. I had one for the 1999 Sprites balloon that I had out here. Um, it can't. I don't think it's that one because that's too skinny. Maybe it is. No, this is for my Japanese experiment. But this is actually a pretty good example because, except that we have the calibrate. Virtually the whole thing was designed in its entirety before we fabricated anything. So there's a third one of these out here on this table. Maybe it's the one right behind your right knee. Um, yeah. This is actually this is my. But again, this illustrates the amount. I think this is the South Pole Balloon Campaign one. But the example is there. You have to design. You really have to write down your designs, and not as little scribbles, not as stuff like this, but as real drawings. And if you're not using CAD, you still do it on engineering paper with a ruler and a sharp pencil, so people can cope with understanding what you've done. I've spent way too much time looking at really literally back in the envelope scribbles and saying, no, that's not a drawing, and having students in this project look at me like wounded sheep. We've got to be professional. So I don't want to get any more. I have to order this part. I have from somebody who hasn't otherwise shown me their plan. The designing by assembling the parts and seeing how they go together is just not how this is done. But I do understand why some of you feel that's necessary. You just can't design without having pieces. You can't do that in the world of engineering employment. Bechtel doesn't work that way. Okay, so that applies specifically to Erica, who is the one who is doing that, bringing me a part order at a time without actually showing me any drawings. Daniel Canales tried it, and I wouldn't let him. Okay, so what else about the test flights? We have to have the payloads all the way assembled and ready to do environmental testing by the 28th of July. Now the thing we're not necessarily going to be able to do, but I hope we can do, but we don't have to, is Dr. Leffer actually records the waveform. So we can decode the data later. But actually the hardest part of this from a software perspective is the decoder. It's given the go-bys and the examples that come with the Arduino, you have virtually nothing to do in programming the Arduino. It isn't that hard. It's just cut and paste and you're done. And I could probably do it in about an hour, maybe two. But it's the other side that's hard. particularly if you want to actually read the data and just don't want to see numbers on the screen. If you want to have a GUI that updates, that's hard. That's why it's really unfortunate we don't have something producing signal now. Because we don't even need the transmitter and receiver. You can take the bit stream that you think you're going to produce and start writing decoder software for it now. That's where we need to be. Okay, so we could have potentially two separate experiments, one on each device. The other issue I heard about from last week is that somehow the concept of multiplexing is not well understood. Hamza came in and talked about what he had told everybody, and I said, no. And I'm not really sure. Yeah, maybe we'll go over the PDR and then I'll go back and talk about it. Multiplexing is not 5 seconds of one experiment, then 5 seconds of another, and storing in the meantime, and time stamping, and then sending all of that in a bunch. That is not what we've been talking about when we talk about multiplexing. That's a complete misunderstanding. What we have meant all along by multiplexing is that if you have, say, 16 variables you want to transmit, or 12 variables you want to transmit, you transmit variable 1, variable 2, all in all, and then you transmit a synchronization signal, four bytes of a unique pattern. And then you transmit all of your data from the second set of samples, having redigitized everything, next line. So the multiplexing takes place within each line. You're not doing anything at all to store it up and then do one experiment in a chunk and then another experiment. That is not what we've meant by multiplexing. And I have no earthly idea how that concept developed. It reflects a profound misunderstanding. That's one of the reasons I was hoping people would be here, so I could correct that misunderstanding. Yeah, the problem is I suspect that misunderstanding is sufficiently profound that at this point there should be people speaking up with questions.
Did either of you have the previous understanding of multiplexing?
No. No.
Okay.
Now, I can either illustrate now or I can wait till we do the PDR first.
Let's illustrate now.
Okay, what I'm going to do is screen share, and we'll go with full screen and start screen share. And I love that. Okay. I'm starting Excel simply so I have a table format to talk to. Okay, now let me talk about what I'm trying to represent here. I'm trying to represent what is going to turn into a serial data stream. That means that the actual data stream is going to go out reading left to right, first line, second line, third line. Okay, everybody understand that?
No.
Okay.
Where lines?
Here on the spreadsheet.
Okay.
So if we have now sync 1, sync 2, sync 3, and sync 4 are an arbitrary 32-bit word that is fixed and known and it usually we could probably find the sync word in one of these. I wonder what happened to the. I wonder what happened to the book I'm actually looking for. Most of these recent projects that are our projects, actually, either this one or more appropriately the sprites balloon, actually specify. We use the same sync word every time, and my colleague Jim Benbrook looked up. There are sync word pattern generators that generate an appropriate sync word, and they are in part structured so that the sequence of ones and zeros gives you an easy to lock feature in biphase L.
I don't even have half of the words.
Okay. The sync word is a unique 32-bit pattern. It tells you when the data frame starts.
What's a data?
The data frame is the format of the signal that you're using to transmit the data.
What's an example of a data?
I'm trying to write one down here.
Okay.
I'm trying to think if there's anything like a real world example of a data frame that we could talk about. Actually, the internet, TCP/IP, with its packet switching, the structure of the packet is a data frame.
What's a packet?
Oh, the data that comes in from the internet is broken up into discrete amounts of data of a certain length.
Like
Number of words,
3 words.
16 bits.
It's a measurement of data, so like a number of bytes.
It's a measurement of the number of ones and zeros in information is represented digitally in bits. Either that's a single number, it's either a 0 or a 1. For the purpose of most computation, organization, and message transmission, these are organized into larger clumps. The standard clump is 8 bits, an 8-digit number, an 8 binary digit number. That's called a byte. Now, depending on the system and your convention, that byte can also be considered a word, or most systems work with 2-byte words as their word length. Some work with 4-byte words. But a word.
Pictures made out of words?
What?
Are the pictures that show up on websites made out of words?
Yes. They're actually made up of bytes. Usually, no, not necessarily. Depends on the format. But a JPEG, I think a pixel is 16 bits, or it can be 24 bits, which is 3 bytes. Really, that depends. That's very format dependent. But what you usually think of on those pictures is you have a byte string of some length. So a data frame is an organized sequence, an organized list of words, a specified length long, that's the same content every time. I guess I did this on a Monday and you weren't here. I actually went over this one of the Mondays.
I'm not asking for myself. I'm asking are here and can ask questions.
Ah, okay.
It's important, if at all possible, to discuss this subject using a basic vocabulary
I'm trying to. Bytes and words are about the bottom line. The data transmission is accomplished by sending a string of binary digits. Now, in order for that to have meaning, that string of binary digits has to have defined boundaries that establish what is in the content of this string of binary digits.
So the way multiplexing was explained by Hamza to most of the group was that it's basically a traffic director, and that it's getting, let's say, 4 signals in. So signal 1, you go. Then after a certain amount of time, it says stop. Signal 2, you go. A certain amount of time, it says stop. Signal 4, you go.
Yeah, fundamentally he was wrong.
Fundamentally, how would you change that analogy to explain how the situation actually works?
Okay, a multiplexer is a switch.
Okay.
The multiplexing, you see, there are two separate functions here. There's multiplexing and there's sequencing. The multiplexer we've been talking about is a switch, an analog switch, which means an analog signal is a voltage that can have any value, and it is just a voltage. And it is not represented numerically. It's a line with a voltage on it. A multiplexer is simply a switch. It's actually done nowadays as a chip, but think rotary switch. Is this, when I started off?
I don't know what a rotary is. I've never seen a rotary.
Or like a dial?
A dial.
What is, I'm not asking how the multiplexer does its job, I'm asking what the net effect of the multiplexer is.
Yeah, I mean, I keep getting shoved further and further away from logical presentation. A multiplexer is a switch that can switch any of some number of inputs, typically 8, to a single output. What that multiplexer does is it selects which quantity goes into the analog to digital conversion chip to be turned into a digital number.
That sounds like a traffic circuit.
Yeah, I'm not sure what the difference is between what you're saying and it takes in a number of inputs and it passes one at a time. Like, according to a control.
The difference is the way Hamza explained it. It sits on that one input for a long time, and you build up a huge column, and then you go to another. That isn't the way we're going to do it at all.
Okay.
But as far as like the operation of the multiplexer itself, it has a certain number. You said usually 8 possible. Like it has 8 analog streams, and it passes only one at a time by a control. Is that?
Yes, but
still
you don't do it
correct?
that way. You don't do it as a stream. You do it as a single value.
That's fine. So he was not fundamentally wrong.
It's just in the application.
Okay, no,
of it that
he
it's
was
wrong.
fundamentally wrong in that he was using multiplexing in the sense that he was doing time chunk multiplexing in a way that there's very little relationship to the actual data handling process.
But that's still how the multiplexer works, even if we didn't understand how the multiplexer is used. But that's still how the multiplexer works, though, right?
I really dislike the analogy. The analogy is very confusing and incorrect. It's a switch. It's just a switch. And thinking of it as a traffic director is incorrect. The traffic director is a higher level of logic. It's the switch is what the
The
multiplexer
traffic
is.
director, okay, we're getting into syntax here. We know that you have to tell the multiplexer on, off, 1, 2, 3, 4. The multiplexer doesn't decide that.
Right,
We
right,
know that. We have to write a program that does that.
right,
And we
right.
have to get the Arduino to tell the multiplexer this is the program that you're supposed to use to send the data.
Right. Now, by the way,
You let 1 card through it every time, or you let 2 cards from 1, and however you want to split it up, we have to tell it that. We have to
correct.
figure out how to tell the Arduino we need to figure out how to speak to the Arduino that this is what we want to tell the multiplexer, and then we need to get the Arduino to tell the multiplexer.
Actually, that isn't hard because the Arduino system world comes with so many examples and go-bys with each piece of hardware. Virtually all of that is provided. which is, but yeah, I'm dealing with a sort of somewhat different conceptual misunderstanding, and I think that thinking the traffic director is what decides what the switch does. The switch is just a switch, in my mind.
Okay.
Yeah, so it's a switch controlled by the Arduino.
Yes, that's all it is. Now, by the way, I think one other thing is this is an analog switch. So signals like the weather shield, which already produces digital output, don't go through the multiplexer or the analog to digital converter at all. They don't. That is a different part of the flow process. The signals that instruments that produce pre-digitized output, the particle detector, turns out the weather shield, those get handled differently. That gets handled at the traffic director level. The multiplexer is just a switch. That's all it is. It's a switch you decide what to do with. Now, this data, the data frame, once you collect a set of quantities, let's explain the concept of data frame, which is really where we are. You're sitting there on a radio. Now, if you're looking at the SD card has a series of bytes, because most memory systems are organized by bytes. You read a byte, you write a byte. And you can read and write them in a certain order from a certain starting place. So actually, the problem, now I think the SD card write organization that's available in the Arduino is pretty primitive. So we may just want to record the data stream that we also send out. Maybe faster, but if you're just sending numbers, the numbers have no meaning unless you know two things, where a word starts and a word ends. And if you know which word you're looking at. So a word in this context is a number. So imagine somebody sitting at a typewriter and going, and actually meaning the absence of blanks in the first line makes it incomprehensible. So what a data frame does is it tells you where the blanks go. So
That's a good explanation of data.
You have to dumb it down.
hmm?
You have to extremely dumb it down. It's a point where
at 10 months into the project, this is terrifying, but okay, so what has to happen in the data system, and I have covered this before, and there are actually recordings out there that could be reviewed. The data system has to collect both the voltages and turn them into digital numbers, and the digital numbers that are being produced by the experiments that produce digital numbers natively, and organize them into a specified order. Now, what Hamza was talking about last Friday was that you would sit there and take a stream from one experiment for a while, and that's the part where he went totally wrong.
Okay, so, but most of his analogy doesn't change, only the time length does. It goes to 1/2 of a second instead of 2 seconds.
A much better analogy is, okay, you have an 8-seat chairlift, and you have 8 separate lines for each seat, and you have the gates.
Separate lines?
8 separate queues.
One for each seat?
One for each seat. A well-organized ski area does that. Or if you have a Um, what is an equivalent of a whole bunch of parallel admissions for people in lines? Um, the
Say a bunch of lines in a movie theater.
um, oh, uh, if we want to do traffic, a toll booth. The Imagine we had a synchronized toll booth in which the gates went up all across the toll booth at the same time for each one car. Back down, and then you reload the toll booth, another car. Starting line for a horse race. You have 8 horses all in a row, or 16 or 20, then the gates open all at once. That's a much better analogy for the kind of what we're doing here than taking one stream from here and letting it run for a while, then taking another stream from here. The gates open at once, but they open for one item. Now, it can be more complicated than
I
that.
don't understand what the first thing means. You mean all the gates open, but they only open for one item?
Toll booth. You let one car through, gate goes back down.
So is this for
So
the
how do they all
word
pass through the
creation?
same ABC? Like, so all 8 horses pass through the same.
Oh, that's what the
Tiny
multiplexer
two.
does. It cycles 8. So then the 8 horses are now in the starting gate. And the starting gate opens and lets them all into the data frame.
Okay. So is this all to create the intelligible words of the right format and length and meaning?
Now, because the structure of the data handling within the computer is done by words, you're either handling bytes or you're handling words, and you're writing bytes and words. The lining it up by bit isn't necessary inside the computer. It's lining it up by words that is. When you're putting it on the radio, you have to be able to reconstruct where the word boundaries are. You don't know that. So the RS-232 format gives you a natural word boundary structure. And you can, from the RS-232 format, identify where the bits and words are. That's intrinsic to the format. I'm not going to go into those details because I don't remember them off the top of my head. It's complicated. But then what RS-232 does is says, okay, now you have a byte. But it doesn't tell you anything at all about the order of the bytes. Which byte is this? Now what a data frame is, let me be a little more specific here. So let's say we have temperature, and we have pressure, and we have humidity. Okay? Those are all the variables that are coming off the weather shield now. I don't actually know what the word length is on those. I didn't know they were intrinsically digital until 2 days ago. Nobody ever told me. But let's say we organize them into 16-bit words because that's what happens within the Arduino more or less automatically. Those numbers are going to be organized into 16-bit words whether we want them to be or not. Doing more efficient data packing is going to be very hard, at least within the kind of software available on board Arduino with only 35K bytes of software to use. So now let's say we're flying with the TEC. So the TEC produces, and I'm not even going to guess what those words are, but you've got so actually let me do guess. Sat number, phase 1, phase 2, and sat number, phase 1. let's assume we do the look angles by post-processing. The look angles being the directions to the different spacecraft. That's something you can get from spacecraft location tables that are available on the internet. So, and so forth. So let's say that's all we're or let's actually, you probably want to have three, so that we take the three highest, what the hell, gain spacecraft, and so we have something that looks like this. Now, I have no idea what the outputs are going to actually be from the TEC experiment, but that's something. Now, that's a data frame. This list of digital values is a data frame. Now, typically, what you do actually, because of the way decoders work, is you actually may want to 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 12, 1, 2, 3, 4. That's 16. Good. So 16 is a good number. The way data decoders work is they really like to have powers of 2 in the frame length. That may be archaic. That has to do with hardware-based decoders. When you're doing purely software-based receivers, that may not be required. Okay, so there's the data frame. Now, what our telemetry team is supposed to be doing is their first step is designing that. And I did say that in one of my Monday classes. And if we have two experiments, one on the IMET R and one on, now the IMET R, you take this at 1200 baud, and the IMET itself mixes that with the variables it's measuring. And those, how you do that, I don't know, but I believe that is done with IMET management software that's pretty easy to use. And Darryl, I believe, knows how to do that. And none of us understood what drove Erica off into outer darkness of looking for how to reboot the IMET. Because Dr. Leffer told her several times she didn't need to do that. So somewhere in the IMET documentation are instructions on how to interleave. So what you will get from the IMET is the IMET sync words, the IMET's variables, then the 1200 baud data stream we've provided, all interleaved somehow. And how that happens, I don't know. But it will end up looking something like this. Now you can, one of two things can, now let's keep it simple, stupid. The dirt simple data frame is just one line. And that's probably all we need to do for the test flight. For some of the payloads that are more complicated, now let's say we're actually digitizing Rachel's data, where you want to go, you know, the slowest the transmitter we bought will actually do is 9600 baud. Okay, so now reporting the temperature, 9600 baud, that's bytes per second. So that's, what is a half of 96? 4,800 words per second. That's, if this is 16 word frame, that's 300. 300 frames per second. Okay? So 9600 baud with a 16-word frame will produce 300 frames per second. Now, Rachel's data, she wants to do that. because even if she samples at that rate, she's only going to be looking at, thanks to Nyquist theorem, that's only up to 150 hertz. So that's really the low end of what you might be sampling with your detector. Your data, you might want to do that. You might want to actually sample your variables at 300 samples a second. You actually don't need to. One sample a second is fine. But there's no way in hell you need to sample the temperature or the humidity at a data rate of 300 samples a second. That's absurd. So what do you do? Well, what you do is you do what's called supercommutation or subcommutation. Depends on whose viewpoint you're using. But you see these four, you can have a multi-line data frame. So you can have let's make this VLF1, E field, BX. So we have now, let's suppose we have a 16 by, suppose our data frame, besides being 16 words long, is commutated by a factor of 16. Let me illustrate. So we go and we now over here you can put the words that you're going to sample 16 times slower. So we can have temperature number 1, temperature number 2. So that can be inside temperature, pressure, humidity, VBAT, VBAT2. So we can have all the battery voltages. That's called housekeeping. It's a very good engineering practice to transmit all that stuff. Then over here you can have time code 1, TC2, TC3. Now the fact that time code now I have no idea what else we'd put in here. You know, there are examples of full up data frames found in some object books. If I could find the one I was talking about, the one from, it may have gotten put back in here somewhere, but the one I had out from our 1999 project had a really fairly detailed one. And so you see things in each of these guys, and they're all of those are sampled. This would be lat. Actually, I've been somewhat inconsistent here. It doesn't matter, but the reason I've been inconsistent is that the sync words it's 4 bytes. So if we're talking words here, then we actually only have Here, why don't I do this? Make it consistent. And now we're dealing entirely in words. And then this can be latitude and longitude and latitude. And this, by the way, yeah, okay. So we that gives you 32-bit precision on your position information if you need it. And then whatever else. In big complicated payloads, there are usually a lot of voltages you have to monitor, a lot of temperatures, and there are a lot of variables that are measured that are, only change slowly by some of the detectors. So you would put those in these. So if this is 300, if there are 300 of these a second, in fact, we're missing a couple of words here, so you'd probably have something in columns O and P as well. There's 300 of those a second, then, and you have 16 subframes, these are called subframes, then the stuff in the subframes are whatever, they're sampled about 20 times a second. That's still ridiculous for temperature, but it's somewhat better. So that's what's meant by a subframe data frame. So this is, and I tried to get everybody to start getting ready to think this way by asking everybody to list what variables do you need to transmit, at what precision, and at what rate. I did ask for everyone to produce that table for their experiments. And the reason is that once you have that information, you can then plan, and then you know which experiments are going together on a payload. Then you can plan your data frame. And so the really important thing for, when I talked Monday week, when I lectured online, I talked about how to do the flow chart for the actual flight software flow chart, because that's going to be constructing a data frame. And so the multiplexer, you see that some of these come from a multiplexed ADC, whereas some of this stuff, at least if we're using the weather shield, temperature, pressure, and humidity, that is available digitally through the I2C bus, which is a proprietary bus that lets you bring in digital data from lots of different devices. And the problem is, I don't know if that comes in as a single byte or as some larger number of bits. I don't know what the precision is of those detectors. But Chris was saying before the meeting started that some of you think that the weather shield will talk to the multiplexer and then go through the analog to digital converter.
We now know that's not true because the weather shield uses the digital signal and therefore doesn't need to go to the multiplexer or the ADC.
Right. And no digital signal goes through the ADC ever. And those of you who think somehow it was
signals don't need to be converted to digital signals.
right, there was some degree of misunderstanding, I am told. We hope we have corrected that.
Dr. Barron, I need to leave pretty soon. Did you want me to say anything about the GPS that you wanted?
No, I wanted to address it. Can I hand it? And then you can put it back where it goes.
Mm-hmm.
I don't know what people were doing when they bought these two things. Somebody said that this came with this. Is that really true?
That wouldn't make much
They
sense.
connect.
No, they do
That's the
not
problem.
connect. Yeah, Hamza was saying, Hamza and Abdul were both saying that they came together. They were ordered together, or they were shipped. They were sold together. That makes absolutely no sense. If it does, then we've either been ripped off or the vendor is making no sense. Because this does not fit on that connector there. And I actually sincerely doubt, I don't think that's a connector.
The wrong size or the wrong type, or
This
actually
isn't the,
not a
this is actually not a connector as far as I can tell.
connector.
I have no clue. It's not anything I've seen before. If it's a connector, it's a very tiny, fragile one. It's not the kind of connector I have ever seen. It, I guess it could be a connector, but
Can you go back to video instead of screen share? Show what part on the
okay. I hope I can. All right.
green arrow.
Okay. Here is the connector for the antenna. It's a standard RF connector of some description. It makes sense as an antenna. It's going to plug into a fairly hefty matching, probably right angle bracket on the surface of some card somewhere. What is claimed to be the input of this by the way, this is how you kill things. This is in a plastic bag by itself without being in an anti-static sponge. You're putting things in these little plastic bags, you put them in anti-static sponges first. Otherwise, they don't go in plastic bags, they go in aluminum foil, and there are rolls of aluminum foil out there before you put them in that little plastic bag. Electrostatic discharge can occur in this configuration that will destroy this. We've got to be more careful. Okay? The sponges that they're shipped in, that isn't just shipping material. Those are electrically conducting sponges, and they should be stored in those sponges if they're not actually on a circuit. And I have said that before. I don't know why people aren't paying attention. I guess there are people working who don't listen to the recordings or something. Okay, this connector here, where is my...
The power button there.
The connector right there,
The white box?
no,
Above the white mat.
above the white box. You see that little tiny thing above the white box?
Which type?
The one on the left of the white box, little white doohickeys with a cylinder. Now, Hamza and Abdul told me that is the antenna connector. Now this is an actual antenna. The white box.
If that's an antenna, why do we need the black thing?
Boosts the signal.
Hmm?
It boosts the signal, is
Mhm.
what they were saying.
These are too alike for that to be the case. It's so that if this is buried inside an insulating box, you don't have 2 inches of styrofoam, which could be enough to kill the signal between this and the free space. If we are mounted on the hasp down underneath the hasp someplace, and this doesn't have a free view of space, this was the intent, because this can be put on top of a much larger payload and can see free space. That's the point, not that you get that much more gain. The problem is if that's a connector,
Is it possible that it's a wire connection that was supposed to solder?
no. If you look at it, you'll see this is an actual coaxial connector. If it's a connector, it's a snap-on coaxial connector with virtually no mechanical integrity.
That's bad.
We do not have the mating connector, and we do not know for sure this actually is the connector. I'd like to get some confirmation that this actually was purchased. When I inquired on Wednesday, what everybody said was, yeah, they came together. This is why we need to have more people here. It would be nice to get whoever it was
Do
who...
you have any reason to disbelieve the people who said that they came together?
No, it's just, except for the fact that it makes no sense. The intrinsic absurdity of shipping these two things together to go together is like, what? So we have to figure out, we either are going to be in a situation where we have to figure out, first off, will this work with 2 inches of styrofoam over it? I have my doubts, actually. Or how do we connect this to that? Or can we get a different approach? We don't need...
That is officially the telemetry team's... I would like to go ahead and say that's the telemetry team's new objective. Test that under 2 inches of styrofoam.
That's what I was going to work on today, was getting making sure we can talk to that with the Mega, because I had that talking to the Uno last week, and obviously we want that to be working with the Mega. And then also to look into how the heck we're going to get the wired bit connected.
What are we using as a receiver?
Right. Well, last week when we got the GPS stream, we just connected that onto an Arduino Uno, connected straight to my computer, and we took the serial out and launched that. So we're going to work.
Is that the Arduino outputting data, or is that the transmitter outputting data?
The transmitter outputs the data directly to the serial out through the USB in the Arduino.
What transmitter are we talking about?
The GPS there.
This is not a transmitter, it's a receiver.
Okay, the GPS sends its received data through the Arduino, through USB, into the computer,
Okay.
which we monitor by serial.
Right. That in the world of things that involve radios, transmitter is a very specific word. It means it's actually emitting. A digital signal, a wired signal, we need another word for. I mean, that's a
Yeah.
So it is my understanding that this is, now the other thing that I heard from the report from your work last week was that somebody was looking at an existing cable and saying, well, I wonder if we could just, now it was one that doesn't actually mate to this, but can't we just cannibalize that? And the real answer is not just no, it's hell no. If you need a connector to mate to this, buy it and build the cable. The raw, we have drawers full of raw connectors. We probably have one, but if we don't, that's the approach. You have to start thinking like we're actually fabricating stuff. We're not just shopping.
When you say fabricating, the word connector and the word cable are 2 different things. At the end user point, a cable and a connector are typically the same thing. When you say connector, you mean the thing at the end of the cable.
Yes, I mean the thing.
The actual wires that go into that connector, which then mates to another connector on a different cable, those wires that are typically insulated are called
Wire.
cable.
But yes, one can build an actual. It is jargon dependent. One tends to think of building a harness when you're putting. Actually, I think you're right. You're correcting me correctly. A cable has connectors on it. You build a cable by putting connectors, raw toast, on wire to produce a cable. That is sort of the way to think about it. Usually we get very sloppy because context makes it clear. Put that connector on this cable means you're putting the cable on a block, on a piece of naked wire. Yeah. And trying to do that by dismembering an old experiment is not the way you go. Every one of those connectors you guys were looking at last week was built by undergraduates from the raw parts. Now, that takes a good deal of dexterity that even I don't possess. I used to have undergraduates do this because, well, they were more dexterous and could see better. By the time I turned 40, I couldn't see well enough to assemble this kind of connector. Requires visual acuity that 40-year-old people don't necessarily have. But yeah, now this one was assembled by a machine. But you can come pretty close to this level of quality with an experienced technician. Most of the cables you'll see around here connected to payloads are actually built here. Gotta start thinking like that, because some of the stuff we're gonna have to do that. But
I need to head out now. Do you want me to take that with me, or do you want me to leave it?
put it back where it goes in the other room, please. And see if you can't find a piece of
I'll do that.
a conducting sponge to stick it in. Okay. I think you're up now. I think we've gotten through my major rants of the what is a data frame and how are the data organized for transmission was something very clear from my discussions with Hamza needed to be gone over. Now, are there any more questions on that before we go to the PDR?
For what?
Data frames, data organization. So we have to figure out what the hell is going on with that. I guess before we go to the PD, the other things that have come up, I'm getting to the really ghastly ones. When I started to ask questions about do we have the connectors for the transmitter? Oh, we've gone through that. We are going to go ahead and buy the whole shooting match. But then we'll try and decide if we have to actually fly the...
Can you fill out that order for my time?
That's a big chunk of change, but I guess my budget for each one of those was $3K, so 1,100 isn't that bad. And, okay, I guess the last piece of reality for me, I think one of the reasons I thought we might want to go ahead and fly 2 experiments, one on each transmitter, is the information that Rachel and I have, but nobody else has yet. They're not providing us with zero pressure balloons from Alaska. Not only that, they've forbidden us to fly them, even if we went out and bought them. Yeah, but this is for the record. Ostensibly, there are 13 people here. The 14. I wish that fellow had showed. Or is it a woman?
It's a man.
This project needs more girls.
I also agree.
My comment on the Run Like a Girl video,
Yep.
Science Like a Girl. You can get 2 Nobel Prizes. The only person ever to get 2 Nobel Prizes was Marie Curie. So that's the subtext of Science Like a Girl.
No girl in their right mind would give this project a point as a secret.
My point would be, but We need your organized minds.
Not their problem.
The Rachel, you have not understood the motivation why most women get married.
I don't think anyone does.
Oh no, I understand fully. It's this person is my project. I have to get him right.
That is why most women get married.
That's why most teenagers get bad boyfriends. Motorcycle boyfriends.
Okay. Can you mute yourself?
Okay.
I think if you get muted, I get. No, at the top. The microphone on the line.
There you go.
Okay. Now.
Okay.
So now try.
That appears to be working. We'll see if it. Okay, so yeah, y'all can see me now, so that's good. Or see the presentation that I'm showing. So as soon as I can see it, we'll be all set. That's it. Yep.
I'm not exactly clear on how they ordered the transmitter. I see an order form in here for the transmitter and its antenna, but they had that whole long email conversation with the guy. I'm wondering, I don't know if I can talk to them and say, hey, we're getting the whole thing wrong.
Yeah, I mean.
Yeah, find the form that has the transmitter on it, see who requested it, and talk to them.
No, I mean I think we
How much do we pay for the transmitter? What? How much do we pay for the transmitter?
$400.
What's it called? I see like an order form for a $74 transmitter, but from Levels actually.
It should have been from Arduino something.
No, it's this.
It's from Pacific Crest.
It's from Pacific Crest, and this is supposed to be $400, and you need to find that and send you a change order for the whole kit.
The order sheet's not in.
Okay, for whatever reason it's not working, so I'm just gonna send you.
I do not have email on this box.
Okay. Do you know your username and password? Because you're logged into your Gmail.
Oh.
You don't even need your username and password. You just need to open a browser and go to type in gmail.com.
Actually, I do not have to do that. Because I'm already in. So just do this.
What is this?
I just sent you the email to eabearing@gmail.com.
There we go. Now, I hope you saved this. I can't open that. It'll be right now.
Why not?
Because this only has 2007.
Okay.
It needs a 2010 format. Sorry about that. I'm going to do that conversion. I'm going to go to, I think, a human element range extension.
Okay.
The one thing I didn't talk about when I said I referenced the fact that we're not going to be getting, and then talk about the other half of the problem, which is that it looks like the Sweden piggybacks will be really fun.
Is that the old one or the new one?
The old one. No one's coming away with it. I'll keep it in mind.
You should be able to open that one.
Okay, yeah, that's. Okay, so, saving it to drive or use for people.
It's in the Google Drive. I shouldn't want to direct you to where to go to it, but I can just send it to you.
Well, it's in your Google Drive. I don't have access to that.
You want access to that?
No, he wants me to do it the way.
It's probably best. You probably need to have a place where you can share private documents about. It's crazy. Here we go. So this is just for the piggyback.
Because that's what you told me to do. So that's what I did.
Yeah, that's absolutely, because we're not ready for anything else.
That is, yeah, just.
I guess I should turn my microphone back on.
And I'll turn mine off. Hang on.
Or no, you're going to talk to it. I'll just put the screens up.
Okay. Yeah, so that's it. They were trying to have it done by June 29th, but it's not done, so now the new trying date is July 6th. That is just something for us to keep in mind. It'll be deleted when we actually present the PDR, but when it is finished, we should go back and go to that slide and see if we meet all those objectives. Well, the next couple slides are the overview and the subsections, mission overview, system overview, subsystem overview, and then the next one, I think it's a prototyping plan and then the project management plan. So the mission statement for the piggyback is to develop and test prototypes for the ultra-lightweight science packages. Our goals are to generate readable data, prove concept for long-duration travel, although that's not really a primary goal anymore, transmit data successfully to the ground station.
Long distance is more
Okay.
Um, it can also, it will, make sure that we can actually carry out our main mission when we go into the field.
So that's what I was trying to outline some specific goals that would be readily for us to test on this piggyback mission that would be applicable to
Okay.
what we're doing here.
I would be astonished if this was ready. I didn't even know when we were trying to get this one done.
Okay, so here's the thing. Let me tell you what a radio sonde is. A radio sonde is the weather shield in an Arduino and a transmitter.
Oh, okay. All right.
That's all it is.
Um,
So the weather shield, the
Okay.
GPS shield, and the Arduino itself.
I read the title, and I was thinking all of the trace gas.
Right. Yeah. And so maybe I should not call this gaseous compounds. I should call it something else. But
Just call it radio sonde.
okay.
Now let's go back up to mission overview.
Yep.
I think what you're really trying to do is to demonstrate to the students how to put a payload together and make it work.
Okay.
Okay. All right. We have got to stop using the term UPOT. That is a proprietary term of the University of Colorado. Was it the University of Denver or was it actually the University of Colorado?
I have no idea. I have no idea.
Okay, it's a proprietary term of the collaborators that they were working on.
Okay.
It's not our term.
Okay, so I was saying that we should call it the 2-pod because we are trying to mimic. Gaseous compounds is trying to mimic the U-pod. They're trying to take that and then build basically a copy. Potentially more lightweight, since that's what we need, and any improvements that they can make. But
yeah, it's that. First off, the acronym will not be meaningful to Brenda.
okay.
And secondly, it's a proprietary.
Our test site will primarily benefit the gaseous compounds team. No, that answer is not correct. So all other teams on the project, it doesn't matter who the teams in the project will benefit from. What we need to be talking about is why it would be good to make a cheaper IMET-R, because that's basically what this is doing, is trying to make a cheaper IMET-R.
Yeah, basically what we're trying to do is to get to a position where we can extend. The best way to say it is we want to get homemade radio sonde working to the point where we can extend it by adding more sophisticated instrumentation. That's really what you want to say.
Okay.
And don't distinguish the entire team will benefit because we will learn how to do an Arduino-based telemetry system. That's really what we're doing. The entire team benefits. It's not just gaseous compounds. Really, there's a good deal of obsession in having a GPS sheet. Now, the only experiment that I know which actually needs it is yours. Because all of the others, the GPS tracking data will be provided either by the spot. No, actually, I'm misspeaking. The spot quits working at 60,000 feet, doesn't it? So yeah, I guess we do need above 60,000 feet, unless we get the little APRS device, $75 device. Okay.
Please tell me if any of that is wrong.
All right, I'm reading it.
The things in small text are notes. They're not supposed to be read.
Expect to see if you expect to see spectra, don't say the high concentrations, just see spectra from 0 to 20 kilohertz. And you,
Well, so I want to have an idea of what my results will be. So I'm expecting to get so much. I'm expecting to get more of this kind of data than I am of these frequencies.
right, what you really expect to see are, in the auroral zone, are examples of auroral hits and whistles. That's what you want to say. You want to correlate the hits with auroral observations. You may actually want to have a GoPro on your flights when you actually put your flight payload together. I wouldn't do that. Very little distortion. Altitude mapping is not necessarily part of the issue here.
Okay.
You will see higher activity in the auroral zone. Zone is the word you're looking for there.
Okay.
Usually where there are aurora, it's called the auroral zone.
Okay.
It's just north of the twilight zone. The conventional devices have found that the aurora produces extensive VLF activity, something like that. Okay.
So you say we're going to have 2 payload kits, right?
Two experiments, all going on one payload.
Two experiments on payload. So that's just the weather shield and Rachel's VLF experiment.
And the IMET-R.
And the IMET-R. So
Okay, no. The IMET-R can have an experiment attached.
I don't think we should do that at this point in time.
Okay. Then we don't have to fly an IMET-R.
I think we should fly the IMET-R in order to compare it against the weather shield.
But we will fly the IMET, but it can be a plain IMET. The IMET-R is more expensive.
Okay.
The IMET, if we don't want to put additional data in, we'll do that later. Then
Well, we're gonna get it back, right? And we want to fly an IMET-R anyway, and the IMET-R is the one we would want to fly. So let's test the IMET-R.
okay. But the R feature
Won't be used
will be used. Okay.
in this piggyback flight.
So this TEC slide won't be anymore?
We're keeping it in case they get it ready, but I don't foresee that happening. I mean, so I have it in the PowerPoint, but I'm going to hide it, and
Well, yeah.
and we need to go over it anyway for when we have the next one. So let's discuss it.
Signal delay is phase difference and
Can those be considered the same thing? Two different terms for the same thing? I'm considering editing that by saying calculating the signal delay, in parentheses, phase difference.
the signal, okay, in the context of GPS,
Mm-hmm.
and I guess I'm being too technical here, the signal delay is actually the elapsed time from transmission of the spacecraft to reception by the receiver. It's the difference in signal path between the two frequencies that is important. So it's the difference between
Difference in signal delay.
difference in signal delay, yes.
Yeah. Okay.
And that isn't. I guess the reason I said put it as phase shift
Mm-hmm.
is because to the extent that there are professionals, and Brenda has regular NASA professionals listening to this.
Right.
That's how what they will understand.
Yeah.
Um,
That's smart. I like that.
The
That will be included. From a dual band GPS receiver on board the payload.
Now, what is not clear here is that we were. This is a concept.
Okay.
The TEC is path dependent. You make this measurement for each satellite that's being detected by the GPS receiver. That's typically somewhere between 3 and 5. And what that does is it actually gives you a geometric pattern of ionization in the atmosphere above you. So, as the spacecraft moves, what you get is you get an indication of where, in what directions there are a lot of electrons and what directions there are fewer electrons. And the fact that you have multiple spacecraft passing through enables you to sort of map regions of high concentration. And this is usually done with multiple stations, and by comparing multiple stations, you literally do tomography.
Wasn't it? What's that?
Same as medical tomography.
What's medical tomography? Because I'm not a doctor.
Well, have you heard of CAT scans?
I've heard of a CAT scan. That doesn't mean I know what it is.
Oh, okay. A CAT scan, and the T stands for tomography, is where you take and you use what are in fact total absorption measurements by X-rays. You shine an X-ray beam and you just rotate the X-ray beam all around the subject, and you do it this way, and you end up with a 3D picture. That's tomography. And tomography actually refers to the mathematical technique used to unscramble the signals. Okay, so that's what's going on with the TDC.
Is that first sentence correct?
Which first sentence?
Number of electrons between 2 points along a tube of 1 meter squared area.
Yeah, it's basically the total number of electrons between the receiver and the GPS, each individual GPS satellite. And it's actually the total number of electrons per square meter. That's not quite. That's sort of. Let me say it the way I would say it. The total number of electrons per square meter along the path between the receiver and the GPS spacecraft. C stands for content, not count.
Oh. I knew that. I don't know why I put con.
I have no idea what the cell phones.
We wanted to try to do it with having 2 cell phones and then measuring the GPS delay difference between those 2 received things. But then we were told that it's not possible or it's exceptionally difficult to do that as opposed to having a dual band GPS receiver.
Yeah, that's totally different than what this says. This says not that we're using cell phones as the GPS receivers, which is interesting, but that you're using the cell phones for telemetry.
Where does it say that?
Very last bullet. What's that about?
That was something that got cleared up a long time ago. I'm assuming this slide's quite old.
Yeah.
That got cleared up when Ronnie was still here. Because Dr. Costner actually came in, he asked her, is it possible to use cell phones to transmit the data we get from the receiver down? And she said she did allude to the fact that the MIT team is actually doing this. It's actually tried to do that. But it'd be exceptionally difficult and not exactly within our mission statement.
I don't know how. I do not know if it's possible to use a cell phone for data transmission for an external digital data stream at all.
Right.
I mean, certainly, cell phones do a lot of data transmission. And you can configure. We actually use cell phones. We use iridium phones on spacecraft all the time. For one of those phones. Okay, so that's a cooperation. I've been over that side of these records. Yeah, no, that is this box here.
Okay.
That is what happens.
What happens?
What happens is that either your timer runs out and you have a timed cut down, or the CSBF staff decides to cut down and you're going to cut down.
From a zero pressure?
Yeah, on the zero pressure. It's either timed or commanded.
Okay.
The equilibrium no longer be sustainable. Usually, let's just not go there.
Okay.
And since we're not doing that anyway, that's
Timer sets off and disconnects payload from balloon.
this is just to be completely done.
Don't use that one. Use the next one. That's a hidden slide. Critique that one. That one might be equally as wrong, but that's the one you need to critique.
Okay, first off, these are two separate systems.
What is?
This little box down here on the lower left,
The IMET-R and the IMET-R receiver?
yeah, that's a separate experiment. Now we're actually putting two experiments on the HASS balloon, and it would be best to show them as separate block diagrams. Because they really completely
Okay.
I see no reason to put a spot gen free on this experiment.
Why not? That may be a completely valid thing to say. I just want to know why not.
First off, I don't think we'll have access to the region of the sky where it can see the GPS receivers and satellites it talks to. Because I suspect, we're going to be tucked into a slot on a big old payload.
Mm-hmm.
There's no need for it. The CSBF is providing all the tracking we could need.
Okay.
And if we actually want to do flight tests, which we might, of the Spot Gen 3, we do them here with Darrow and those payloads that go up every day.
Okay.
In fact,
Do you know if we have a Spot Gen 3 on order?
We have one here.
Okay.
Now, one of the that brings me to a problem. What does SPNO stand for?
Signal processing and output.
Okay.
Why is that SPA?
All right. Well, the reason we have the CAN bus is that's the SD card. Isn't it?
Yeah.
The reason we have the GPS is so that this can produce time code. The one thing that's missing. Okay, I have two of these slides, one for the INET, and a solid arrow like this inside a single block is not how you show a radio line.
Okay.
This broken arrow outside that does show, we're not going with 19 kilobaud, we're going with 9.6.
Okay.
And actually, I doubt very much that this would be the standard payload.
Why? Why?
First off, we don't need the GPS shield on most of the experiments. We only need it on those experiments where you actually have to have time code.
Why would that not be all experiments?
Because the time code is, you have to have on-board time code. The
Arduino does not provide time. It provides 1, 2, 3, 4, 5, 6, 7, 8.
the ground state.
Okay.
That would be my. Now, I guess if it doesn't take too much weight and power, that's okay.
Which ones
Right.
need time code?
Yours,
Why does mine need time code and nobody else's does?
because you need to somehow put time into your other recorder.
It's going to do that from I turned it on at this time to what point I am in the song.
That really isn't accurate enough.
I don't know how else to do it because it's all going to be on one track.
Yeah, I do. We never quite got there in our conversation. I guess you may not be able to do it with your store-bought receiver. But when we get to the point of doing our own receiver,
Okay.
that on the last filter stage, you just have another input from you mix inputs, and it's really not hard.
Okay.
And that we can do that easily with. Now, if doing it with the totally store-bought approach that you're taking for this flight, you can put a little coil around the antenna and pulse it once a second.
Which would tell me what?
Exactly where the second mark is.
Why would that be different than where the second mark is in track playback?
Because the recorder is not a precision scientific instrument, and its time drifts rather substantially.
Okay.
At least that would be my. I could be maligning the recorder, but it's not intended for this purpose. Your
That's true.
recorder is missing block here.
So it's a subsystem, and it gets explained later.
Yeah, I guess.
The only thing that really has detail, unfortunately, is the standard payload.
Yeah, but you could put a single block audio recorder.
Yeah. Okay, I'll do that.
The reason the weather shield may not become part of the standard payload is the weather shield. It's not a scientific instrument. We want to replace that with an actual scientific instrument. It doesn't. The whole business of using a thermistor which is mounted on the board, that cannot produce meaningful atmospheric data. You need to have it out and ventilated like the booms on the iMac.
Okay.
The other reason why this won't be on the standard payload,
Why what won't be on the standard
the
payload?
weather shield,
Okay.
is that the standard payload is going to be an experiment with an Arduino. It's going to look like this, except instead of the XDL micro, the iNet bar is going to be in the place.
Can you use your mouse to point at the screen instead of your fingers?
The reason I don't is because I'm used to my teaching software.
Yeah.
This isn't going to be on the standard latex payloads. It's a $1,200 expenditure, and we don't need 3 watts. What we'll be doing is putting the 1,200 baud data stream into the IMET-R's external data port.
Okay. I would like to hold off on that plan until we know how much of the IMET's data takes up that 1,200 baud.
The 1,200 baud is what the IMET will accept, in addition to its regular data, I believe.
I have no confirmation of that fact. I've been trying to get confirmation of that fact, and I have not been able to obtain it.
Who have you been talking to?
Everyone who deals with it. Erica, John, anyone in that group.
Daryl is the person you have to ask this question.
Okay, well, I've met Daryl exactly one time,
Okay.
so...
Yes. My understanding from Daryl and Dr. Leffer is that the IMET-R will take a 1,200 baud input in addition to its own data stream.
So what is its transmission capability?
What I just said, the 1,200 baud plus its own data stream.
Okay.
Now, that does need to be, you're right, that does need to be checked. But you probably check it by looking at the IMET-R specifications, so they're available online.
That's what I've been trying to find out.
But the weather shield, flying the weather shield with the IMET-R is completely redundant. The IMET-R is a scientific instrument that's calibrated and does accurate scientific results. The weather shield is a toy.
So we're trying to produce a scientific instrument, and we need something to compare it against. So if we need to know how bad the weather shield is compared to the IMET-R.
Right.
The IMET-R will get real, accurate, precise data. The weather shield will produce whatever it produces, and we will compare those, find out how bad it is, and then whatever we make, whether or not we use the weather shield, will be somewhere between those, hopefully, and not less than the weather shield, and almost certainly not more than the IMET-R.
Yeah, as well.
But August 2nd, that is our standard payload.
Standard payload implies it's what we're going to fly on every flight in March.
All right.
And that's
There's just not going to, standard payload will not be on, it's not a concept that will be presented in the August 2nd flight.
All right.
You can delete that box if you want. I deleted it on the master copy, so.
The weather shield, we certainly, by flying the IMET and the weather shield in separate but adjacent, we will find out just exactly how bad the weather shield really is.
That's a good thing.
The fact that the thermistor, the temperature measurement, is mounted on the board means it cannot have real scientific validity, and it won't work in daylight because you won't be able to shadow it. It has to be hidden from the sun. System design physical model.
We don't have that yet, but we need it. That's what I guess Erica's
the place where you need the physical model, or the thermal model, that XDML, this, you have to figure out whether you have to cool it or heat it. And there needs to be some fairly careful thermal modeling I mean, somebody needs to be designated to go work with Dr. Dunbar and get some guidance, because this is a fairly potent heater, and in all likelihood it will get too hot. But it also can't get too cold. It won't work below -40, and that is the ambient temperature up there. So we have to have the right combination of insulation and cooling to make it work.
And when you say that, you're talking about the telemetry shield,
Hmm?
the XDL Micro.
The XDL Micro is a 3-watt transmitter consuming somewhere around 6 watts of electrical power. A 6-watt heater can warm up one of those picnic boxes pretty well. We need to be sure it's not going to get too hot. We need to be sure it can withstand being at -40.
Okay.
So thermal modeling is critical. Now, if we actually fly the extremophile experiment, that needs thermal modeling because it can freeze.
The extremophile experiment? What are you talking about?
Yeah, it's got water in it. What's this?
I've been trying to find a balloon user's guide, but I don't know if one exists. So instead of having the template that they gave us was a rocket, so we're doing a balloon.
Okay, you don't need center of mass. So what you want is a mass estimate. Are you using high voltage? No. We're not using any ports, except all we're using is an on-off relay. Here's a place where I think the way people have been doing things is really going to come back to haunt us. Because all of this comes from web page to web page and do it all on your iPad and without documenting stuff. There have been trade studies like that. Can you show them? You guys haven't been keeping your records in orderly way.
Not to my knowledge.
No. I've been keeping it, not working. I have a sign.
I mean, you're one of the people who needs to deal with Bullet 2. I mean, particularly for the next PDR, everybody needs to be able to deal with this slide. You've been over this slide with the team? This is
Yes.
the first one. Yeah.
I told them they need to give me a trade study, and they need to give me a risk matrix, and they need to give me a block diagram, and they need to give me an explanation of the risk matrix, or of the trade study.
That's good. That's good.
It's not finished.
Hello. Hey, sweetie. Oh, okay. You know, I'm kind of in the middle of a meeting. Your plane should be boarding soon, shouldn't it? Oh, you just boarded. Oh, okay. I thought you said you were bored and wanted to say hi. Okay, so you just boarded. You're on your plane. You got your luggage organized, and things are looking better. Well, have a great flight and solve the coastal management problems of the world. I'm sure you will. Okay. No lecture though. All right. Bye. My daughter, her plane to the Peace Corps mandatory training, which starts in an hour in Los Angeles.
Oh, goodness.
The plane was canceled at 8 a.m. And she's got on one. She got on one we paid for $600, and the Peace Corps was the church. This is a sample, right?
Yeah.
Okay, so we don't have that.
We've been doing a lot of getting caught up on the block diagram and all the parts preceding this. So
I do have a sense that the rest of the team could be helping more.
there's a lot of could be helping more, could be asking more going on. So we just need to find an effective way for people to work together and.
Each time I ask for more, people find reasons for why they can't. Or they say they will do it and then it because they have this to do.
Always get a deadline.
Even with the deadline. Even if I say give it to me in an hour, the next day it still won't be done. Like I don't know if they ordered the. I gave Hamza and Abdul task of ordering the Arduino battery and
The orders have not come through.
I know. I was looking through the phone, like, okay, what about it?
Do they not understand the concept lead time? Those things might not come if they don't get ordered soon.
Honestly, I'm just going to have to do everything when it comes to instead of ordering the batteries and such.
Part of the problem.
They were more concerned with getting the transmitter stuff done. I can talk to them and say that.
Well, we do need to get the batteries ordered too. Part of the problem is that I think things that I think take 20 minutes take 6 days. Why? So we really are not aware. This does not look like you could. Now, have you actually made an appointment with Brenda yet for this?
No.
Because you guys are.
Should I make one with her for the August one, or should I only make one with her?
Ask her
Okay.
if she wants to do a PBR for them. So unless we have the risk matrix. I don't understand risk 1. High temperature will cause no data. And that needs to be written much better.
Okay.
The risk is the payload will overheat and break things. Actually, the risk is payload will overheat. The consequence is the instrument will cease working. But you also have risks of the kind that people you aren't talking about here, which are very much we're running into. The integration schedule will slip due to delays in procuring the science instrument. The integration schedule will slip due to delays in designing the science instruments. We've been countering those risks. That's the kind of thing that really does need to be in the risk management table.
Okay.
Is it really the University of Colorado or is it the University of Denver?
I do not know. But that doesn't need to be in this one anyway. Anything with gaseous compounds on, you might as well delete, because it doesn't need to be there. I'm not even going to put the radio sound as a subsystem. because it's too difficult to explain. It just doesn't fit into the subsystem idea.
Okay, so I seem to be telling some of you guys this, and like the long lead time item for your experiment are the connectors. Okay, Rachel, you made a huge amount of progress in this, but we still aren't there on Gantt charts.
Yeah.
And
When are you going to be here tomorrow?
I'm not going to be here tomorrow.
Okay.
I
Can you
spend
stop
some
the
time
broadcast?
in the afternoon online. Well, my laundry is, and I actually have. Michael, no wonder they weren't getting anything. We didn't go back to being from here. Oh, you were talking.
Potentially, I don't know.
Yeah, that's what was going on. You were talking, but my screen wasn't being shared.
Yeah.
Huh. Oh well. Okay, guys. Team. We're having a real problem here with people responding to things they say they're going to do in a timely fashion. You really all have to focus on getting your agreed assignments done quickly, because we're running out of time. The Gantt chart review for each of you was supposed to have taken place 2 months ago. And the reason we're really running out of time now is the one thing that's supposed to happen is that when you really have a deadline, well, okay, do an all-nighter, take a day off, get the job done to meet the schedule. But you don't know what the schedule is because you've never gone over your Gantt chart with me. And I think I know why. You want to show me a perfect Gantt chart. Until you can, you don't want to do it at all. Since you don't know what a Gantt chart is in many cases, you're not dealing with it. That doesn't get the job done. The opposite is the approach. You come in and say, you asked us all for Gantt charts. What is that? What software do I use for Gantt charts? Rachel's found a recommendation that's free, I think. The university provides Microsoft Project to all of you free of charge, although apparently there's some difficulty in loading it. The IT staff of both EA and physics are available to help you do that. They know this is a funded research project, and therefore you can just ask them, and they will help you, and it doesn't take them very long. And what bothers me a lot more than you're not knowing what a Gantt chart is you're standing around not dealing with this because you don't know what a Gantt chart is. I'm happy to tell you, but I'm far less happy to have you not fall farther and farther behind schedule because you don't have a scheduling tool at your disposal. That's really the issue here. But there are a whole lot of you who don't seem to be doing very much. And some of you take on tasks and then nothing happens. And maybe you mean well and something comes up. You've got to find a way to work around that something that comes up. Maybe it's skipping sleep. God knows I've been doing that lately. Maybe it's taking a day off from work. Whatever. You've got to stay on schedule. And I'm not going to go over some of the... So the batteries need to get ordered right now. The connectors need to get ordered right now. What else needs to be ordered right now? Anything else that hasn't been ordered? Now this, I'm going to be in on the 16th of July. That'll be my only day between now and when we should be starting thermal and vacuum testing. A word to the wise, take the day off so you can work. Or move your work schedule so you don't lose any money, but can still work. Okay, so now the last thing, I don't know if it's been announced, but we will not be flying zero pressure balloons from Fairbanks. Long duration experiments, your flight opportunity is going to be a year from August in Sweden. It's not clear we have the budget to take many of you to Sweden. We can make the budget available by basically saying, look, the folks who haven't been working and have no real identifiable contribution to the project don't go to Alaska. And that money will be used to take the people who really deserve it to Sweden. We do need to have a plan of which experiments have to go to Sweden. We do need to begin to start to develop a plan of our different component. We're going to launch 7 different payloads from Alaska, each twice. The experiment complements need to be assigned. I'm going to be back on the 28th of July, and hopefully we'll be in a position to start testing, or complete testing. I'm going to go and show Rachel and Chris how to work some of this stuff. Dr. Leffer and Darrell can help you with the rest of it for his graduate student. And we'll know more about the Sweden situation in August. What I'm going to also be in, I will get to Fort Sumner the evening of Thursday. I'll be there for 2 or 3 days. Otherwise, you guys are pretty much going to be on your own. You're going to do this yourselves. What I'm going to want to have happen is when the first week of school is I'm going to want to meet individually with each one of you and review what you have accomplished personally over the summer. Attending a lot of meetings is not what I'm going to want to hear. I'm going to want to know what concrete work product did you produce that will actually be on the payloads in some form, whether that be a design effort or actual fabrication of a circuit over the summer. And we need to go forward from there. Okay, that does it for me.